Good morning and welcome to day 2 of the College Lecturers Day. I am Fiona Geary and I work in knowledge transfer for Arable and Horticulture, sitting between research and our on-farm knowledge exchange team. So I hope those who joined yesterday found it interesting, and welcome to those who are joining us for the first time today. Can we go to the next slide, please? The recordings for yesterday's webinars will be available soon on the AHDB website and on YouTube. So just going to do a little bit of housekeeping before we start. Everyone's microphones will be muted throughout the duration of the webinar, but we do encourage you to ask questions using the chat box on the right-hand side of the screen. If you're having any technical issues, you can also use the chat and we can try and assist you in there. Like the other webinars, this session will be recorded and it will be available on the website and on YouTube later on this week. We're aiming to finish at 11:30 and we'll be covering questions as we go. If we do run out of time, the questions will be covered as part of a Q&A, which will be emailed to you after the webinar. This morning we'll be focused on integrated pest management. If we could go on to the next slide, please. Paul Neve, the head of crop health and IPM, will give us an overview of the strategy, and Joe Martin, Catherine Lambourne and Charlotte Rowley will each be giving us research updates as well as all of the tools and services AHDB have available on pests and diseases. And this covers the 3 AHDB sectors: AHDB cereals and oilseeds, potatoes and horticulture. I'll hand over to Paul to give us an overview of IPM and AHDB IPM strategy.
Yeah, okay. All right, thanks everyone. Yeah, if we could, I don't currently see my first slide yet. Okay, great, thank you. So morning everyone. I'm gonna, and thanks for the introduction, Fiona. I'm gonna give a brief overview of the sort of the work and the program that we're putting together at AHDB to increase our focus around integrated pest management. And the things I really want to cover is talk a little bit about some definitions of IPM and some sort of new definitions that we're trying to develop, or some new sorts of frameworks that we're trying to develop at AHDB as part of our program. Talk a little bit about why we really do want this and need this new focus on IPM now, and then talk about some new areas of science that we think are going to be important for helping to develop new approaches and increase adoption of integrated pest management. And finally, just to say a little bit about the program that we're putting together. I will say that when I talk about integrated pest management, the pest there really refers to all of weeds, diseases and insect pests. So we're covering all of those things, and you'll hear a bit more about what we do individually for those in the following presentations. So next slide, please. So this first slide really just is to give an indication of the sort of the potential complexity that we're dealing with when we begin to talk about integrated pest management. You'll see a number of schemes there which sort of try and summarize, you know, the various approaches which make up integrated pest management. I don't want to really dwell on any of those individually, but I do just want to sort of look at the definition, if you like, just one definition of IPM from the Food and Agriculture Organization at the bottom there. And it's the careful consideration of all available pest control techniques and subsequent integration of appropriate measures to discourage the development of pest populations and keep pesticides and other interventions to levels that are economically justified and reduce or minimize risks to human health and the environment. IPM emphasizes the growth of a healthy crop with the least possible disruption to agroecosystems and encourages natural pest control mechanisms. So I mean, I think that is in many ways a nice summary of what we're trying to achieve with IPM, but it's complex and it's very hard for a farmer to sort of grab hold of that and make that a definition like that actionable and relatable. And I think that's one of the things we want to try and achieve going forward, is actually make the sort of realization of IPM much more actionable and relatable to farmers. And I'll say a bit more about that as we go on. So next slide, please. So as I said, one of the things we just want to start out considering is why do we need this increased focus on integrated pest management now? Well, clearly, it's important to say that chemistry and pesticides, plant protection products, will remain an important part of integrated pest management. So we're not talking about, we may need to reduce reliance on pesticides, but we're certainly not talking about replacing pesticides. But of course, obviously, there have been a lot of plant protection products have been lost to regulation and are still being lost to regulation. We also have rising levels of evolved resistance to many pesticides in many of the major target pests, weeds and diseases that we're trying to control. And of course, there are associated environmental and consumer concerns about pesticide use. And all of this leads in some way to a slowing innovation pipeline. So there are less new pesticides being developed. Some of that because of regulatory reasons, other sort of more technical reasons, because much of the low-hanging fruit has already been picked. And all of that is also at the sort of other end. There's a number of policy drivers which are really putting an onus on growers and farmers to reduce their use and their reliance on pesticides. So if you like, there's less pesticides available for a number of reasons, and a growing policy incentive on growers and farmers to reduce reliance on pesticides. And that for us is why we really need to have this major focus on integrated pest management now and going forward. So next slide, please. So, I mean, I've only been in this job about a year with AHDB, and before that I spent my time as a researcher at Rothamsted Research, and I've been involved in a number of discussions over that time about the need for new approaches in crop protection, the need for greater adoption of IPM, and the problems associated with the loss of pesticides. So I think the need is widely recognised, but I still think we have to go some way towards developing new technologies and developing real, as I say, I'm going to keep using that term, sort of actionable strategies for IPM. And I guess that's really what we want to try and achieve with our new IPM program. So next slide, please. What was also interesting to me is sort of looking at what might be on the horizon in terms of thinking about what might be some of the new technologies, some of the new techniques which might become available to add new tools, if you like, to the toolbox, or to increase our ability to do IPM. So this was just sort of 5 key areas. That this was a horizon scan which was carried out by the National Academy of Sciences in the US, and they asked what would be the major science breakthroughs that they could see in the next 10 years, 10 to 12 years, which would really lead to changes in the way to huge sort of breakthroughs in food and agricultural research. And they talked about systems approaches, and by that what they really meant was they were saying that to tackle some of these complex environmental and agricultural problems that we see in the future, we really need to become better at integrating science and technology with human behaviour, economics, policy. So a much more sort of systemic approach to many of these things. They saw huge value in sort of new sensors and big data analytics, which are increasingly coming into agriculture and helping decision making, gene editing, and microbiome. And I think all of those 5 areas really can be key advances for integrated pest management, for building new integrated pest management systems. Next slide, please. So want to just sort of finish up for the last 5 minutes or so by just talking a little bit about what we hope to achieve with our new IPM program. So much of the research and KE at AHDB going into the future will be organised under these sort of technical programs, and we have 4 of those, one of which will be IPM. So our IPM program, I mean, its overall goal in the centre there is to increase the adoption, the uptake of integrated pest management, and in doing so to reduce the environmental impact of crop protection whilst maintaining productive crops. So we've got 5 on the outside of that. We've got sort of 5 work streams, or pillars, as I've called them here, of activity. So the one at the top is stocking the toolbox. That's very much about just continuing to invest in applied research, applied and strategic research, to ensure that farmers have access to tools and knowledge for a whole range of tools in the IPM toolbox, not just chemistry, but thinking about biopesticides, cultural control, mechanical control, and all sorts of other new interventions. The second one, so going sort of counterclockwise around this, putting the eye in IPM. I'll say a bit more about this in a minute. This is very much about we're keen to really develop an IPM network and a data platform which really understands what's happening out on farms. We do much more coordinated monitoring of pests, weeds and diseases, and understand how farmers are responding to the presence of those, what tools they're using, and which of those tools are most effective in controlling those pests, weeds and diseases out on the farm. We think it's really important, because of all these various different definitions of IPM, we think it's really important to develop a standardized set of metrics by which we can measure IPM practice. So we'll be working with others to do that. Again, we have one here working with partners. We really think it's important to sort of speak with one voice around IPM, ensure that we're all using the same terminology. We all talk about IPM in the same way. And then finally, we've got a bubble there which is around delivering best practice, and we hope to, or we're in the process of developing what we've called an IPM hub, which will be an online presence for all of our IPM research and knowledge, which will make that easily available, actionable and relatable to farmers, growers and agronomists. Next slide, please. So as I say, you know, for us, we've said that you know, IPM is complex, and we think that might, you know, that's one of the reasons why we see, you know, why we need to continue to focus on increasing adoption of IPM. So for us, we're trying to, I showed that definition at the beginning from the Food and Agriculture Organization, a long definition of IPM. We've tried to boil it down to what are the real key components of what we're trying to achieve with IPM. And for us, it's really just about thinking about a coordinated strategy to, first of all, think about what can I do on my farm, in my fields, in my glasshouses to prevent outbreaks of pests, weeds and diseases. And there's a whole range of tactics for that, through sort of cultivar choice, rotation, through design of rotations, hygiene and biosecurity. Then, you know, having done that, what tools are available for detection? So we know there's a whole range of new sensors and diagnostics, remote sensing, that's really providing much more, making it much easier to know when pest invasions are happening, and therefore to target control at the right time and in the right place. And then finally, we're always going to still need control for pest, weed and disease outbreaks and invasions. So again, and for us, chemistry remains important, but it really needs to be integrated with a range of other biological, genetic, ecological and agronomic approaches. So we're not overly reliant on chemistry for control. Next slide, please. Yeah, sorry, next slide. Yeah, so as I say, I'm going to try and speed up a bit through these last 2 or 3 slides so I don't use too much time. But yeah, I've just used an example here from research I was involved in when I was at Rothamsted. This is a lot of my research was focused on blackgrass. This field, you can see a picture from 2014, was a field with a huge blackgrass infestation. You can see it there. You might just about be able to see a crop in there somewhere as well. But if you go back, we went back and we monitored this field year on year, and we went back in 2018, and that blackgrass population had been almost completely cleared. We were doing this over about 70 farms, monitoring 2 to 3 fields per farm. And the idea here is, instead of running replicated field experiments where you look at what might be the optimal management strategies for something like blackgrass, the idea we've got here is actually to understand what farmers are doing on the farm, to set up networks where you can monitor in a systematic way pests, weeds and diseases, but also monitor what farmers are doing in response to those outbreaks and what's working and what's not. And by doing that over a vast network, you can get a great deal of insight into what's actually working on the farm. And I think this is where the idea of big data comes in. It's going to be much easier in future to automatically monitor and to do surveillance for pests, weeds and diseases, but also to collect data on what farmers are doing in response to that and what's actually working on the farm. The next slide. Yeah, so I'm going to speed through these. Just a couple of examples of this is a project in Australia, a $20 million project. And I think we should have ambitions to do. we can and should have ambitions to do similar things in the UK. So, a big project nationwide to monitor for pest-weed diseases, as they say, to put actionable information into the hands of primary producers. And the next slide. This is another example from a similar network or a similar cooperative in the US, where they are basically, farmers are sharing data, and this whole cooperative works on the basis of thinking about each farmer's field as being an experiment. And if you can gather data from all of those experiments, integrate it, you can really then, as the bottom line says, identify which combination of practice really work best in given situations. So again, this is around this big data idea. Next slide, please. So yeah, we also have a major focus. We know that one of the major challenges is in changing people's behaviour or increasing adoption of IPM. So just onto the next animation, this slide. Yeah, so as I said before, we know it's knowledge intensive, costly, timely, or time-consuming, risky, and site-specific. So how do we overcome those barriers and constraints and increase the adoption of IPM? And how do we do that working right across the supply chain with farmers, growers, agronomists, right through to sort of retailers and consumers? Okay, thanks. Next slide. And so this is just my final slide to sort of sum up where we're trying to go with our IPM program. I've talked about this idea of simplifying the message, talking in terms of IPM being about prevention, detection, and control, not just focusing on that control, but building in the prevention and the new detection technologies. More emphasis on evidence-based IPM, so really gathering data off the farm to understand what's really working on the farm. Using this sort of concept of every crop as in some sense as an IPM experiment. We want IPM to become the new normal, and ultimately we'd like AHDB to be one of the go-to places for IPM knowledge and information. Thank you. Finish there.
Great, thank you very much, Paul. That was a great introduction to IPM and the direction of movement for the industry. Just a reminder, if anybody has any questions, they can pop them into the chat and we'll cover them as we go. I'd like to introduce our next speaker, Jo Martin, who will be covering the weed element of the IPM programme at AHDB. So over to you, Jo.
I think you're on mute currently, Jo. Sorry to jump in. Give that a go now.
Can you hear me now?
Yep, that's better. Thank you.
Brilliant, great. So yeah, thanks Paul, thanks Fiona. Yeah, I'm Jo Martin, part of the Crop Health and IPM team at AHDB, and I've been responsible sort of for weeds within the team for the past few years. Recently moved positions to look after pesticide regulation, so looking after a lot of minor use and EMU approvals within horticulture, but also an increasing need within potatoes and cereals and oilseeds too. So in terms of weed management, what I've tried to do is give you a bit of a flavour of the work that we've undertaken at AHDB over the past couple of years across the different crop sectors to help address some of the issues of weed management that we're seeing. And hopefully you'll see that as we go through the slides. So next slide, please. So one of the things that we do at AHDB is we try and track active ingredients and their potential for loss, whether it's based on whether they're going through renewal within the EU, whether or not there's a potential for endocrine disruptor, candidate for substitution, etc. And we flag these up, which really helps us in terms of looking at what potential problems that we might have coming around the corner, and also to help us where to focus our research in terms of looking for either replacements or alternative technologies to help growers still achieve a level of weed pest or disease management. Next slide, please. So within potatoes, they have been experiencing loss of active ingredients. So one particular key one was diquat, and also the loss of linuron as a residual control. Next slide, please. So across Spot Farms, we carried out a number of trials over the last, in 2019, where we were looking at residual herbicides, and at that point, aclonifen was only just coming through for a registration in the UK, and potentially at a lower rate than the rest of Europe had. So we wanted to look at it across our Spot Farms just to see how it would work on its own and how it would work in combination with partner mixes. We also wanted to look at a replacement for diquat, so how carfentrazone ethyl or shark would work as an early post application to control those very small weeds when the potatoes were just coming through, and to look at how much damage there would be potentially on those potatoes if the application timing was pushed quite late in terms of potato emergence. Next slide, please. So the contact sites, so we had a number of trials there where they were small plot demonstrations. So our growers, levy payers were able to come out and have a look at those levels of damage a number of times. And in terms of the level of damage, what we did find was that going beyond the label recommendation really wasn't a good idea. We did label recommendation is 10%, and we pushed it sort of to 50%, and we did find some issues in terms of yield and potato tuber distortion as well. In terms of the residual herbicide trial, when we looked at that, we found that the aclonifen was quite effective, but it really needed to be applied as a partner mix. And we did quite a lot of work in there looking at costs to growers in terms of their choice of herbicide. And that could have quite a big impact in terms of profitability for growers, depending what mixes they were going to use. Next slide, please. Another area for potato growers with the loss of diquat is how they were going to desiccate their potatoes. Diquat was probably one of the mainstream uses that growers had in terms of stopping their crops at the end of the season to enable harvest of the crops. Next slide, please. So these trials have been running for 2 years. Some work was also carried out this year. And it was really thinking about life after diquat. So it was thinking about those products such as carfentrazone or pyriflufen, and how growers could use those, the use of pelargonic acid, and then also thinking about mechanical methods in terms of trying to get that desiccant. So it was really thinking about those on an indeterminate varieties and also seed crops. In 2020, then we really wanted to think about that hard to stop situations and how we could get some decent levels of desiccation on those really green growing potatoes. And part of that was thinking about reducing the inputs of nitrogen that maybe you could get that natural process of desiccation starting, which would assist in terms of those other products being applied. Next slide, please. The sites this year have been at all 4 spot sites, and you can see there some up in Scotland as well as in England as well, on a number of different varieties. So Maris Piper, one of the most common varieties that's grown. And you can see that we also looked at reduction in the level of nitrogen applied compared to the standard RB209 guide. Next slide, please. So that gives a bit of a flavour in terms of potatoes and some of the work that we've been doing there. In terms of horticulture, for a long time has struggled in terms of having sufficient products for growers to maintain their pest, weeds and diseases. And the Scepter Plus programme, which you might have heard about, has now been running for 4 years. And it was really about trying to plug some of those gaps. Next slide, please. As you can see here, a quick infographic in terms of some of the numbers that we've been looking at. And we've looked at over 240 different products for a whole range of pest, weeds and diseases. In this year, there were 25 work packages planned, and we did manage to get about just over half of those conducted. And we've had some really good involvement from the different crop protection companies. And part of that is getting the minor use approvals, and we're up to over 15. That was back into October 2019, and a number of applications are still ongoing. And there's a whole range there of both conventional products, but we're also more keen now to look at some of the biopesticides or bioprotectants, as we're starting to call those products, and to seeing how we can fit those into some of the different growing practices that our growers and levy payers have. Next slide, please. So you can see here, this is some of the products that have come through that we identified as being good in terms of efficacy or crops and or crop safety within a number of different crops within horticulture, and those minor use approvals that have come through. And as I say, in terms of bioprotectants, then there's at least 18 products that we've identified which will be and could be useful for growers to take forward for the future. Next slide, please. So just as an example here, so weed control in outdoor salads, particularly difficult are crops such as baby leaf. So for these trials, we carried out some baby leaf trials, which were grower-led trials across the country. And we also carried out some work on some whole head lettuce. One of the big issues that for the baby leaf crops that growers face is crop contamination. So weeds such as groundsel, which if they aren't controlled sufficiently, then the whole crop can be refused due to groundsel being poisonous. Next slide, please. So for these trials, we had a whole number of different treatments, and you can see, I just put up the treatment list so you can see it there. We do code until we get approval by the manufacturers to uncode, because obviously it's not approved for use for some of these products at that point until the minor use approval comes through. But you can see that on this particular trial, we had 3 application timings to try and hit those flushes of weeds as they came through. Next slide, please. As part of the Scepter Plus programme, knowledge exchange and demonstration has been a key part, and obviously with COVID this year that hasn't been possible. So what we are hoping to do starting early next year is there will be a series of webinars. I think we've got 6 booked in for the different crop sectors, so feel free to link into those when they become available, and they should really demonstrate some of the outputs that we've had for the programme and how they can be linking into some of the future in terms of IPM as well. We're planning to carry on with this type of work moving forward once this round of Scepter Plus funding finishes. So again, look out for that when that comes through. Next slide, please. So weed resistance is a huge issue, and Paul was showing that earlier with some of the blackgrass issues that our growers in cereals and oilseeds have faced. And this has led to a couple of projects that have been ongoing now within cereals and oilseeds for glyphosate and looking at that, and also some work being carried out on brome species too. Next slide, please. So I just thought I'd sort of bring this one up in terms of glyphosate, and product stewardship is becoming more and more important to try and maintain the armory that growers and have to ensure that the products that we are using and are maintained and are able to be used for as long as possible. So one of the products which was projects which was the reducing the risk of glyphosate resistance has come up with some quite clear messages, and you can see there in the yellow and blue boxes in terms of preventing survivors, making sure that the maximum efficacy is maintained by using the right dose at the right time, using alternatives where possible, so such as cultivations and other non-chemical practices, and then also monitoring, so that monitoring how well it has worked, and ensure that we're getting tested survivors to check and work out where the drop in control might be happening. As you can see, there is a fact sheet which I'm sure Fiona will be able to have pointed to when you look at the handout as well, so you can find out more information there. Next slide, please. So that's some of the work that has been ongoing and is still ongoing. In terms of IPM and weed management, then this is something that we're focusing on for the future. Next slide, please. So as part of this work, we carried out a weed review, and that is now published on our website. And this looked at the whole cycle of weeds. So you can see here the weed cycle, which is a slide that RSK ADAS kindly allowed me to use. And it's about thinking about all areas across the growing system. So thinking about what you can do in terms of killing weed seedlings, all the way through to mature plants, stopping seed set, trying to prevent that seed return, reducing the level of weed seed within the seed bank as well. So it's right across the rotation as well, and not just that growing crop. And also thinking about on-farm hygiene, such as making sure things like combines, etc., are thoroughly cleaned, that you're not transporting contaminated soil from one area to another, a whole range of different areas that need to be considered by growers as we move forward, especially as we lose more and more chemistry. Next slide, please. So within the team, we've been carrying out a bit of an exercise recently in terms of where we think our research should focus. And certainly for weed management, we haven't specifically gone right down to weed species level, but more about thinking about the overarching areas of work that need to be considered. So particularly areas such as understanding the biology and the impact that the integrated weed management might have on the biology of weeds. There is some thought that there may be a bit more of a push for sort of spring germinators coming through now with change in management practices. We need to think about glyphosate. Glyphosate comes up for renewal in a couple of years, and we don't know what the outcome of that will be. Hopefully positive, but it's about thinking about those implications and mitigation measures that we might need. Continuing the work in terms of herbicide resistance and product stewardship. It is clear and understanding why products are beginning to lose efficacy. And then moving forward, very much thinking about precision in terms of weed mapping, understanding the technology that might be coming through to give growers, again, longer term use of some of the actives and clever use of the actives, so that we're hitting the weeds in a particular way, and not in some cases actually applying product to the crop. And then thinking about those non-chemical methods of control, so mechanical weeding, and that's an area that we do sort of keep a watching brief of at the moment. And then we did, excuse me, we did have some specific area. We did, excuse me, and we did think that volunteer potato management was quite a nice area to think about, because it doesn't just impact for potato growers, but it can impact on growing other crops that might follow that rotation. Next slide, please. So a little bit in terms of thinking about those tools for the future. I think, like I say, it's a bit of a watching brief at the moment. Precision application is going to be quite clear, but we do see a lot more in terms of robotics coming through. There's a number of projects that we're aware about that are developing these areas. And also things such as electric weeding. There's a number of companies now that are trialing this and are using this in different countries. Next slide, please. An area that we got involved in, and this precision area, was a project called Eyespot. This was funded by our field vegetable sector within horticulture. And this was looking at a robotic system and some precision application where there was camera technology to identify the weeds, and the application would apply a specific droplet. In this case, it was using glyphosate, but there was potential to use other products. And it meant that there was a lot less runoff to the soil. We avoided residues in the crop, and significant reduction, as you can see here, in terms of the amount of herbicide put onto the crop compared to standard broadcast applications. And we see this, and we see a number of projects and products where this technology, we think, will move forward for the future. Next slide, please. So I hope that gives you a bit of a flavour for some of the weed work that we've been conducting, and also our thoughts in where we think our research will focus for the future. Thank you very much.
Thank you very much, Joe. A lot was covered there in such a small amount of time.
Bit of a whistle top, yeah.
Whistle stop tour. We have got a lot more information available on the website, and like Joe mentioned, we have got a handout which you should find on the chat bar. You'll see it just above or below, which you can download, and that's got some direct links so that you can keep up to date with the projects, and you can find supporting publications and documents there as well. The next we have Catherine, who is going to cover AHDB's disease work in terms of IPM. So thank you very much, Catherine. You're on mute, I think, Catherine.
Okay, that's better. I was struggling to unmute it. Hi there, my name is Catherine Lambourne. Like Joe, I'm a senior scientist in the crop protection and IPM team at AHDB. And my remit is to look after diseases across the crop sector. So I just wanted to talk to you a little bit about some of the work that we're doing within the programme, and sort of some examples really to get into a bit more detail around some of the work or ideas that Paul's already suggested to you in some of his earlier slides. So there'll be a little bit of repetition, but hopefully a bit more detail to add to that. Next slide, please. So when we think about crop protection, generally there's a sort of a layman's view, I suppose, of this is what crop protection looks like. It's worst case scenario to sort of think of it in that sort of situation, and most farmers are not using that type of technology now. But it's a picture that certainly sort of lay people or consumers, I think, often have in their mind. The next slide, please. So this is a little bit of repetition of Paul's slide, and I won't go into the detail about it, but just to sort of reiterate that times are changing, and there's a number of different activities that are going on, sort of that have become drivers really for the change to an IPM practice, and sort of moving on away from sort of those conventional thinking into a much broader, more holistic approach to controlling diseases in crops. Next slide, please. So again, you saw this slide from Paul, And what I want to do today over the next few slides is really just to get into some detail and examples of the type of activities that we might think around those prevent, detect, control components of the IPM programme. So in the programme that Paul is leading within AHDB, this sort of main components of this work fall under the stock in the toolbox work stream, which is one of the ones that Paul showed you in some of his later slides with that wheel with the bubbles around the outside of it. And I'm actually leading the stock in the toolbox component of that work, which is really all of the research and knowledge exchange that we're already doing, but making it really sort of now focused around this sort of mantra and making sure that we're providing growers with information and examples and the tools and technologies to allow them to uptake some of those new IPM methodologies. So next slide, please. So what I wanted to do was really just sort of break those down and think about this from the perspective of a grower or a farmer, sort of thinking about IPM and a new model for crop management, really. So what we want them to do really is think about these in the order that they're in terms of making some decisions around management for diseases. So on the prevent side, the type of questions that we'd expect growers to be asking themselves as a sort of starting point is, are there varieties that I could grow that have got resistance to some of my main either pests or disease problems that I see on my farm? The next one is, do I know the quality and health of the seed or planting material that I'm planting? And this is really linked to sort of clean start growing. So we know that, for instance, that a lot of diseases are seed-borne. So particularly things like bacterial pathogens can be seed-borne, and also some of the umicate organisms, etc., can often be seed-borne. But there are sort of EPO guidelines, etc., for seed quality and seed health that all producers of seed should be following. And so all growers and farmers should have an expectation of being able to grow healthy, clean seed. But often, unless you ask for the detail of that, or growers ask for the detail of that from their seed provider, there's a risk that they might not be getting quite the quality that they really want. And then also thinking about planting materials. So in horticulture particularly, a lot of material can be grown from cuttings, vegetative material, and those cuttings are taken from mother stock plants, and it's not unusual in my experience to find that that mother stock can be quite heavily infested with different pathogens. And obviously in taking those, when those cuttings are being taken, even the tools that are being used to take those cuttings and then the material that are being taken from can also be sort of carrying and spreading those pathogens as well. So it might well be that you're getting plant material that you're wanting to grow on into what you hope is going to be healthy plants to sell on, already come with built-in infections in them, and particularly if they're bacterial pathogens, they can be almost impossible to get control of from systemic infections. So the next one is, am I doing everything I can to improve my and maintain the health of my soil? And this really sort of links back to a lot of work that AHDB is doing around sort of under a program called Great Soils. And there's some really lovely work going on in a project which is being managed by one of my colleagues, Amanda Bennett, which is the Soil Biology and Soil Health Project. And within that work, we're really getting down into the detail of what do we need to have healthy soils, how do we maintain them? And really what we're thinking about there is, what are the practices, the farm practices, the tillage and sort of ploughing, etc., doing to the soils, the structure of our soils. We need to maintain good structure in those soils and not compact them, because we want them to be aerated. We want them to have a good community of microbiota in those soils, because they can act as competitors and even antagonists to some of the pathogens that we see in the soil-borne pathogens that we see. But also things like increasing the number and diversity of invertebrate pests, for instance, can also really be beneficial in soils. Because if young plants get a good start and grow off well in good healthy soils, they're far more resilient to some of the other disease problems that they might encounter. And then lastly on there, have I given enough attention to hygiene and crop rotations? So crop rotations is not a new idea. Obviously, all farmers, nearly all farmers, grow their crops in rotations, although I've seen some fairly horrific examples of almost monocultures going on, particularly in the horticulture side of things. But the idea of sort of obviously rotating areas where you're growing a particular crop is to stop the build-up of soil-borne pathogens in this instance. And what we really expect growers now, and we know from research that's been done and sort of examples of work we've seen, is that we're really looking at between 5 and 7 years of a rotation to build healthy rotations and try and avoid some of that build-up in the crops. And then thinking about hygiene is often, I think, something that we think about in terms of, in horticulture particularly, we think about it in protected cropping situations where obviously we think about cleaning down crops between glass houses between crops, etc. But in actual fact, it spans right the way across all of the different production systems in terms of sort of managing sort of waste from plants, so things like potato dumps, etc. When there's sort of been sort of potatoes that have come up during the sort of crop preparation for the next crop, or they're left over from previous crops, and they can sometimes be just left at the side of a field. But obviously they're a huge pathogen storage area in reality for all types of pathogens. Even sort of items, ideas like sort of cleaning down tractors and thinking about the equipment that we're using on them, and even walking through some fields that are infected with things like white rot, for instance, for onions, can easily spread those pathogens into other fields, the propagules for allowing those pathogens to develop in other fields. Other ideas are things like sort of getting rid of puddles, for instance, in horticultural settings. So if you think about nursery stock production, we know from previous work that's been done in projects like the Phytothreats project, that puddles even in those areas can act as reservoirs for pathogens, particularly some of the root rotting pathogens, and they can be spread around very easily just on footwear, etc., around crop and infect other crops. So hygiene is a really important area. Next slide, please. Now this looks a little bit of a messy slide, I know, but I just wanted to use this example. It's actually some work that I did years ago when I was working as a plant pathologist, and we were doing some trials looking at this Mycosporella, which is a fungal pathogen that affects cucumbers, and it affects the stem bases and fruit predominantly. So in the production of cucumbers, they grow 3 crops a year consecutively. So they'll start off in about sort of January, February time and grow through probably till November with successive plantings. And when we were doing the work, we were actually monitoring spore levels within glass houses to actually get some idea of when the key high levels of infection risk might be occurring, hoping to target the applications to control those pathogens appropriately. But what we discovered was that what growers were doing was when they were planting the new crop, they often took the old plant off the rock wool block that the plants are grown on and left the base of it just sitting in the alleyway between the rows of plants. And those could often be sitting there for at least 2 to 3 days, and sometimes up to 6 or 7 days. And so if we look quickly at the graph there, hopefully you can see there's a purple line zigzagging up and down sort of in the top part of the graph. And you can see that sort of about 2/3 of the way along, there's an arrow pointing down showing you where the rock wool blocks were removed from the previous crop. And that was sort of, you can see from there that the spore numbers absolutely plummet post the removal of those rock wool, the infected rock wool blocks. And you can see that that type of activity of leaving those around was just increasing the infection risk as the season progressed. But because growers didn't really understand the biology of what was going on with that fungus, they'd no idea that that was even a possibility that spores from those old plants could be moving onto their new plants that they hoped was going to be a nice healthy crop. But the single act of explaining that to them and getting them to actually remove plants completely from the glasshouse and then clean down the glasshouse before they planted new crop actually halved the level of infection in their following crops and in future crops over the years. I still know lots of cucumbers that still maintain that this is much less of a problem for them once they've understood what was actually going on. And it's a simple method for preventing that infection. Next slide, please. So moving on to detect, and again, some of those questions that we hope a grower might ask themselves before they, when they're thinking about managing diseases in their crops. So do I understand what the key risks are that might occur in my crop? So often, in particular areas under different environmental conditions, growers will see sort of key pathogens that will pop up on a regular basis. So we see things like downy mildews and blights, etc., being much worse in the western part of the UK because they have high rainfall levels, and those pathogens particularly enjoy those sorts of nice, cool, damp conditions, and that helps them to spread and infect more crops. So understanding what your key problems are at an early stage, it might help you work out how to manage them. Thinking about monitoring crops for key diseases as well, but also to understand risk. So as Paul mentioned before, there's lots of new technologies where we can think about monitoring for airborne spores in crops, and we've been doing a lot of work with that in different crops, and I'll show you a nice example of that we're doing in the next slide. But it's a really sort of developing area, a lot of new technologies and a lot of automation happening with that, which is really great now. But you do need to understand the thresholds for those diseases that might be arriving in your crop, because there's no point in, if you've got very low levels of infection that aren't likely to be high enough to cause a problem in your crop or cause the disease to develop, then you may not need to take action quite so quickly, but it's really important to understand what they are and when you should be acting. Next slide, please. So this is a tool that's available on the AHDB website, and it's around monitoring and forecasting sclerotinia in oilseed rape crops. So the risk alerts for this pathogen in this crop are provided between March and June each year, which coincides with when oilseed rape crops are in flower. And we update these 3 times a week for each site for environmental conditions that favour the disease development. So what we're doing within this tool is really monitoring airborne sclerotinia spores from a network of spore traps around the country, and then also looking at sort of when the crops are flowering. So obviously a grower themselves will look at this, know whether their crop is flowering already, and then decide whether they need to take action. So we know that infection can only occur when there's spores that are present in the crop and when the crop is in flower. So if one of those isn't happening, then you're unlikely to get infection and you don't need to take action. But we know as well that sclerotinia, as I mentioned before with some of the other pathogens, they like particular environmental conditions. For sclerotinia, we need temperatures above 7 degrees centigrade, and the relative humidity to be above 80%, and that needs to be happening for 23 consecutive hours for that to be a real risk. And this is again back to that threshold. Unless we've reached those environmental condition thresholds and your crop is in flower, then you're unlikely to have a risk episode within your crop. So you can see in the graph and the picture on the right hand side there that we have low risk periods, we have near miss risk periods that are shown as amber, and then high risk periods. And what we'd really be expecting growers to be doing is putting a protectant spray on when they are sort of just before they're hitting a high risk period. So in using that sort of near miss area, if you can see from forecast weather data that the environmental conditions are going to be stay optimum for that pathogen to develop, then that is the time that you would be triggering that spray to protect your crop. Next slide, please. So now we get through to control. So this is the last one in that sort of mantra, but it's also the last one, hopefully, that you should be thinking about in terms of managing crops. So again, just thinking about the questions that growers might be asking themselves. So are there any cultural or control options that I can use to protect my crop before the problem gets out of control? So you know, there are a number of different areas and ideas that growers can try. And most of them will sort of be quite familiar with them, but there's new things coming along all the time. If they do need to then sort of think about going to sort of a chemical control options, what active ingredients or biological products can I use to control this problem? And it's really important to sort of think about those quite carefully. So in terms of sort of putting spray programs together, there's sort of a lot of thought that needs to go into that, because in terms of using biological products or bioprotectants, as Joe mentioned, we're starting to call them now. We know that they have a different level of efficacy, and so excuse me, if growers are going to use them in their programs, they need to think about where to use them, where they can be most effective. So in horticultural crops, they're really useful towards the end of a spray program, because they have either very short or no harvest intervals on them either, and no MRL problems, etc. So they can be very useful just to sort of maintain control when you haven't got a big problem towards the end of the cropping period. But if we're thinking about actually using conventional chemistry, it's really important for growers and farmers to think about what they've used before in that crop, and does the product that they're thinking of now have a different mode of action. And that's really all around thinking about sort of maintaining or avoiding pesticide resistance development, but also in terms of sort of maintaining the stewardship around products and the good efficacy in crops as well. And then also, I think the last thing that you should also be thinking about there is what's the impact of the choices I'm making on my whole IPM strategy. So you know, I think it's a clear example on the pesticide with thinking about that, because if you're doing a lot of development of sort of getting good diversity of beneficial insects within your crop, what you don't want to do is go in with a blanket insecticide that would knock that back. So it's really important to think about what the work that you've already put in, and not sort of ruin all your hard work. Next slide, please. So this is just some information I wanted to talk to you about, really around sort of thinking about that sort of avoiding the development of insensitivity to pesticides in crops. And I'm just using an example of some work in controlling late blight in potatoes. So potato crops are treated pretty much every 5 to 7 days, depending on the weather conditions that are optimal for blight development. And data shows that often we're getting up to 10 applications going on in a crop. I just wanted to pull a bit of data together here. So there have been a lot of trials that have tested the effectiveness of fungicides to control late blight in potatoes, but we're also now able to, we've got the capability of determining the different genotypes. So within the blight populations, we'll have a range of, and a mix of genotypes in all populations, but which genotypes are actually present in there, because actually when those genotypes are developing really rapidly and you're getting a really sort of quick turnover and increasing the number of different genotypes within your crop, what you can lead to is getting some of those genotypes that show insensitivity to fungicides. So a recent example of that would have been 37A2, which a couple of years ago actually showed some insensitivity to fluazinam, which is one of the sort of main staples of crop protection within for potato blight. And so the data shown in the table here just was looking at sort of what are the things that are driving, or what could be driving some of that development of new genotypes within crops. And so they did a sort of meta-analysis. This is some work by RSK ADAS, Faye Ritchie, looking at sort of different components and ideas, hypotheses to see what was actually driving it. So we can see that increasing the dose of the fungicide that you're using does increase the selection of different genotypes fairly dramatically. Also increasing the spray number has again a smaller impact. But the important one here is adding that mixture partner. So thinking about actually using some of these products in tank mixes where you've got a different modes of action, because what you're avoiding there is that sort of selection of new races, etc. And you can see that in 46 out of 51 trials data that they looked at, we could see that they were actually decreasing the selection of new races being developed there. There was again a slight decrease in the selection rate by using alternating sprays as well, whereas adjusting the timing didn't really have any effect at all. So information like that can really help us and growers sort of build really robust programs for maintaining efficacy, but also maintain that longevity of the products that they're using. So clearly, if they have got sort of genotypes within their population that have developed resistance, it means that they're not available to them anymore, and they've got a hole in their armory for controlling them. So a really important work to understand that, and also sort of again get growers to implement some of that thinking around the decisions that they're making. So next slide, please. So just finally, I wanted to think about sort of put a discussion point out, I suppose. Are growers and farmers already doing IPM? Well, we know, yes, lots of them are. But what we do see, and certainly across the different arable and then compared to horticulture, we see a lot of differences between that. So different levels of uptake, but also different levels of complexity and risk averseness, etc. to doing that. So in arable crops, there's been sort of historically a really always good availability of fungicides. They're the prime market for the ag chem companies in developing new products because they're big areas, good sales, etc. So they've usually had good availability of fungicides and other pesticides to them. There's not really been, I would say, in the arable sectors many drivers for change until recently, and that's because I think that consumers don't actually think about, if they're thinking about pesticides and the risks to themselves, they think particularly around, I think, fruit and veg, because they're the crops that they're sort of cooking and eating, and they're thinking about what's been applied to these and how safe are these, and are these having impacts on my own health? Could these have impacts on my own health? Whereas I don't think that many people would think about that in terms of potentially potatoes, but certainly on the cereals side, I don't think they'd be thinking about that if they picked up a bag of flour from the supermarket, for instance. And also, I think that arable farmers feel it's a risky area. Yield is a really important thing to them, and they feel it's probably too risky an option to consider in high levels of complexity. Whereas in horticultural crops, we see always we've had fewer products available. So as some of the work that Joe was talking about earlier on, where we have to get sort of off-label approvals, so some EMUs, where we just sort of get an off-label approval from the main label that's available for some of the arable crops. We also have a range of different production systems within horticulture, so everything from permanent field crops like orchard crops, etc., asparagus, for instance, through to sort of the annual field crops, which is more in line with the arable sort of system, but then right the way through to sort of semi-protected and protected cropping. And what the benefit of that is that when you've got sort of different production systems like that, there are different options for thinking about management controls within them. So for instance, within a glasshouse scenario, you'd be able to manipulate the environmental controls in there. You could also impede the ingress of pests and diseases in there by screening, etc. So there's a lot more control options that are available to them, and they are sort of more sophisticated, certainly within those protected cropping areas. I think there's also more drivers, as I mentioned, sort of conversely to the cereals side of things, again, because it's sort of fruit and vegetables that people are picking up and sort of potentially eating uncooked. So a lot of fruit obviously is just sort of picked up and eaten as it is. But certainly growers still see it as a very risky situation, because obviously for them, if they get a crop failure, which they can certainly do if we think about things like the leafy salads with downy mildews and bremia, for instance, you can get total crop failure within 2 days. Your crop will be just ready for the scrap heap, and that's all there is to it. So, but they've still got to supply their retailer and supply chain, so they feel it's quite a risky business. So all the work that we're going to be doing within the IPM programme and will be really around trying to provide growers with all of the tools and the technologies, and also then hoping to encourage them and increase the uptake of IPM so that they can develop that more fully and produce their crops in a much more resilient and holistic way. That's it, thank you. I think that was my last slide.
Great, thank you very much, Catherine. And like Catherine highlighted, it's really important for us when we are designing research work that we think about the practicalities and the questions that farmers and growers will be asking themselves. The Farm Excellence platform comprises farms across the country, with strategic farms particularly facilitating the link between research and practice. So I'd like to encourage you and your students to get involved with the Farm Excellence farms. They bring together both AHDB research and wider research and demonstrate it in a real business, including things like cost benefit analysis, which adds another dimension to results. And all the details can be found both on the handout and on the website. So yeah, I would encourage you to get involved there. And this brings us to our final speaker, Charlotte, who will be covering the pest portion of IPM. So over to you, Charlotte.
Thanks, Fiona. Hi everyone, I'm Charlotte. I'm also on the Crop Health and IPM team, and I look after some of our work on insect pests. So next slide, please. So just to give you a bit of context for the insect pests that we are concerned with, this is a list of the main sort of pest groupings that affect our farmers and growers. Obviously, no surprise to see aphids and slugs on there. They affect a whole range of crops. But we're also talking about things like flies, spotted Drosophila, gall midges, moths and butterflies and their caterpillars, thrips, nematodes, other sapling insects like capsids. I've missed off beetles, but they're also an obvious pest group that I'll be talking about later. And so looking at that list, it's kind of obvious that we've got a whole range of different species involved. They have different life history strategies. So, for example, might have a migratory period, some of them might have a soil stage, some of the larvae might feed within the crop. And they also have different mechanisms of damage. For example, aphids might be transmitting virus, slugs will be feeding directly on the crop. And so all of these things are really important to think about when it comes to working on IPM research for insect pests and thinking about what strategies might be successful in trying to combat damage from these insects. Also to highlight that we've got a number of different cropping systems, as we've already mentioned today. We've got the wide, the broadacre crops, right down to the semi-protected and protected crops. And so each of these situations, each of these cropping systems has its own sort of challenges and opportunities when it comes to planning an IPM strategy for insect pests. Next slide, please. Going back to the prevent, protect, control framework, I'm just giving some examples of what that might look like for insect pests, and a lot of strategies will be quite similar to what I've already heard about in terms of the weeds and the diseases. For preventers, obviously, the ideal scenario would be to prevent an infestation in the first place, but that might not always be possible. So then it's about suppressing pest populations and trying to prevent damage from occurring, for example, through the use of resistant varieties. In terms of detect, it's obviously about insect monitoring and trapping, forecasting, and making use of thresholds and doing risk assessments based on other data collections, for example, weather forecasts. In terms of control, obviously, talk about product choice, but also how and when that product is applied to be able to minimise the use and make it as most effective as possible. Thinking about any resistance, resistance management that needs to be done, and also doing an evaluation of that control to make sure that it is successful. And actually that evaluation step can apply to the, or should ideally apply to the entire programme at the end of the season, to see if there are any adjustments that need to be made to meet the season. Okay. So here I've just picked out a sample of some of the work that's available on our website, some of the research that's been done in these different areas on different crop pests and systems. And this is just to highlight that we'll have projects that are focused on a particular area of IPM, for example, in the prevent section. We might have projects that cover a couple of these or all three, and some that work on an entire system approach, so looking at the entire IPM strategy. Next slide, please. So for this, I'm just going to go through some of the areas of our work and use the prevent control framework for this. So for prevent, I'll start with talking about some of the research that's been done on a project that was recently wrapped up this year, which was IPM for cabbage stem flea beetle. This was a 3-year project that was led by ADAS, and if you have any interest in cabbage stem flea beetle, I can highly recommend that you check out the final report that's on our website, because they covered a lot of ground in this project, and there's a lot of really useful information there. But I'm just going to be focusing on one aspect of that project today. Next slide, please. So the idea behind this aspect of the project was to look for alternative control solutions, but actually they came up with a preventative strategy. And this is using voluntary oilseed rape as a cut crop. So pest work that's been done has shown that turnip rape and mustard could be used as cut crops, which sort of distract flea beetle from the main oilseed rape crop and reduce damage to the oilseed rape. But again, these cut crops can take land out production, and they can add another element of management. So we were wondering if oilseed rape, which grows up in nearby fields, if they could be used as an alternative to distract the flea beetle from the new oilseed rape crop. And this exploits a potential biological mechanism of flea beetle, whereby we think that once the flea beetle makes its migratory flight and lands in a crop, the wing muscles then deteriorate to provide energy for egg laying. So this means that it's no longer able to make any significant secondary flight. Next slide, please. Oh, could you scroll through? So ADAS were looking at this, and they set up an experiment looking at 2 pairs of fields. And one of these fields was coming out of oilseed rape, and one of them was going into oilseed rape. In one of the pairs, the volunteers were controlled early, so as normal, and in the other pair, the volunteers were controlled late. So they were controlled once the new oilseed rape crop had emerged. Then in the new crop, the salt beetles numbers and feeding damage was monitored. Next slide, please. So as you can see from this site, the strategy seemed to work well. The blue bars represent where the volunteers were removed early, and this is showing you the mean number of flea beetle in the new crop. As you can see, where the volunteers were removed early compared to where they were removed late, we're getting higher numbers of flea beetle in the new crop. And this suggests that where the volunteers are being left for some time, that some of the pest pressure is being reduced in the new crop. Next slide, please. So it's important to note that this didn't work in every situation, and we did see that when there was a smaller area of volunteers left, the result was less clear. And this is possibly because there needs to be a decent area of volunteers available to produce the volatiles that might be attracting the flea beetle into the crop. It might also be a case of different growth stages and the different attractiveness of those growth stages. So the volunteers might not be as attractive as the new crop at the time of migration. And that's something that we're going to be looking at in future work. However, this is a nice example of an IPM strategy that doesn't really have any negative impacts. It's a fairly cheap and easy strategy for farmers to adopt. And it can, if it can lead to some reduced damage, then that employed with other IPM strategies can really start to reduce that risk to the multi-crop. Next slide, please. So, as I said, we started a new programme of work this autumn, reducing the impact of flea beetle on oilseed rape, and this is another 3-year project led by ADAS. In one part of this work, we're actually planning a whole range of different field trials with a number of industry partners, and a lot of these are focused on sort of preventative strategies, so things like companion crops, mulching, organic amendments, and it's all about trying to get the crop to grow away from the adult damage and give it the best start possible. Next slide, please. So for the detect element, I'm just going to highlight some of our pest monitoring services. For aphid monitoring, we have Aphid News, which is mainly of benefit to our cereal growers. And this is based on data that's collected by the Rothamsted Research Insect Survey. So this is essentially a network of suction traps that, as you can see on that map, they're distributed around the country, and they basically suck air out of the sky and collect aphids as they migrate into crops. And so what the team at Rothamsted do is they take this data and they take samples and they count the different aphid species and disseminate this via their website. And we put this into a bulletin for farmers in the form of this table, as you can see. So this gives you the number of aphids that have been collected of a particular species in a week, and then compares that to the same cropping period for the previous year and compares it to a 10-year mean. This gives farmers a heads up as to when aphids are moving into crops and what the aphid pressure is looking like on a year-to-year basis. And a similar network that we have that's more targeted at our potato growers is the yellow water trap network that's run by Sarah. And so these water traps are situated in potato growing areas, and potato agronomists send the samples off to FARA on a weekly basis. The team at FARA look at the contents, they count the different species, and they provide a virus pressure index. So virus pressure is really important to potato growers, and some aphid species are better at transmitting potato viruses than others. So by looking at the composition of species that are being collected in these traps, we can assign virus pressure index, which gives an indication of virus risk for those particular crops. Next slide, please. Another area of pest monitoring that we do is in the form of pest bulletin, and this is mainly targeted at our horticultural sector. So this is run by Warwick University and covers a range of different pest species, not just aphids, that are of concern to horticultural growers, and it provides monitoring information and forecast information for all of the species. Okay, so moving on to control, I'm just going to highlight one of our tools, which is the BYDV tool. The next slide, please. So a bit of context behind this, BYDV is a barley yellow dwarf virus, which is transmitted to cereal crops in the autumn by cereal aphids. Now, previously, crops were protected by neonicotinoid seed treatments. However, a couple of years ago, these were withdrawn. So now growers are relying on the use of pyrethroid sprays to manage their aphid pressure. This tool is based on some work that suggests that second generation of aphids appears after 170 degree days. Now, the secondary generation is the one that actually is responsible for spreading the virus throughout the crop. So the winged aphids migrate in, they'll transmit the virus to individual plants, and then as they reproduce, it's the secondary generation that then moves throughout the crop. So in terms of spray timings and making the most efficient use of sprays, it's better to target a secondary generation rather than the wing adults that might be migrating in over several months. Essentially, this tool is tracking the development of that secondary generation by looking at the degree days in the field based on weather data that we provide through our Weather Hub service. So from looking at this tool and the local weather station, farmers can see that when the line is approaching that red line at the top, if they do need to spray, if there are aphids in the crop and the virus risk is high enough, then that is when they should be doing it best. Next slide, please. So some additional work that we're doing in another phase of BYDV research is the management of aphid and BYDV risk in winter cereals project, which started last year. So this is another 3-year project led by ADAS, and what the team are doing, well, one aspect is to actually see if we can improve upon this BYDV tool and provide a more comprehensive decision support system. And this is based on some work that was done a couple of decades ago on actually trying to model aphid development in the field and understand virus transmission in the field, and be able to develop a tool to help farmers understand the risk to their crop based on aphid numbers and virus prevalence in those aphids. So that's a piece of work that's ongoing, and that we hope to be able to develop into another usable tool. Next slide, please. So I've just given you a really brief snapshot of some of our work on insect pests, but if you want any more information about our insect pests, I can highly recommend the Pest Encyclopedia. This covers pests of cereals and field veg crops, and it gives a really nice overview of the different pest groups. It gives a lot of information about individual pest species, so why they're a problem, the life cycle identification, and non-chemical management strategies. And it also has a nice section on beneficial insects and natural enemies of an insect pest. Also recommend checking out our research reports on the website, and the AHDB Knowledge Library also has some more detailed pest pages if you filter by crops and by pests. And obviously, if you have any questions or want any more information, then feel free to drop me an email. Thanks very much.
Great. Thank you very much, Charlotte. Again, a lot to cover in such a short amount of time. Pest monitoring and chemical control and non-chemical control is actually a theme across all of the strategic cereal farms this year. They run from Scotland into the Midlands and then East Anglia. The links to their web pages will be available on the handout as well as links to all of the tools, services and publications that Charlotte has mentioned. This brings us to the end of the webinar. I'd like to say thank you to all of our speakers this morning and to everyone else who's worked to bring this webinar together. And I would also like to say thank you to joining us this morning. I'd like to draw your attention to some useful resources which will be shown on the screen in a second. The AHDB website contains all of the publications, tools, market information, as well as research updates. So that would be our first port of call for you. There'll be direct links included on the handout as well, so hopefully it will make it slightly easier to find. Next month, or by the start of December, we'll also produce the Arable Research Review, which covers all of the arable, so cereals and oilseeds and potatoes research, which is happening at the moment. If you or your students have any questions, AHDB has got both topical experts and field staff who would be happy to talk to you at any point, and all of their details are available on the website as well. Just a reminder that this webinar has been recorded and will be available on the website, as well as all of the other College Lecturers' Day webinars. That will be on the website and on YouTube later on this week. When the webinar closes, you'll be prompted to fill out a survey, which helps us to ensure that the events are useful to you. We'd really appreciate you taking a few moments to fill that out. And the final session will start at 2 p.m. this afternoon, which focuses on business, and will close the College Lecturers' Day webinar series. So thank you very much for joining us this morning, and we hope to see you later in the final webinar.